So essentially, there has been a lot of questions on how to set up the wiring, even though there is a pretty well done schematic that I've recently made. So to summarize what you need overall, you will require a soldering iron, a multimeter, potentially some Ferrule connectors. This is optional, but it's up to you. It's definitely recommended. However, you won't necessarily be able to use those little connector everywhere that you want, because there are a few spots where you can't necessarily fit those connectors in there with the motor. However, for the main connections using Wago connectors, it's definitely got a better grip if you use those tiny connectors than to use the wires themselves. Even if you twist them, it'll hold, but it's just more of a best practice thing to do, to use those connectors. So you're also going to need some shrink tubes to isolate your wires if you would like to make sure that you're secure. Obviously, you don't want any wires to touch together, as it could create some spark and potentially create magic smoke, which is kind of the thing that you want to avoid. So overall, to be honest, that will mainly be it. You could also require some wire stripper pliers, maybe crimping tools, just if you want to make your own custom connectors, maybe a custom PCB. It's up to you at the end of the day. You're not necessarily obliged to use Wago connectors. For example, there are alternatives like other types of connectors in which I don't necessarily have the name, or you can even manually twist the wires together and solder them. That won't be a problem as long as you make sure that it's insulated and that it's properly soldered together. So overall, that is mainly the tools that you'll be needing to wire your robot. If we take a look at the diagram, basically, we have a lot of Wago connectors on the schematic, which the reason why there are that many is not necessarily because you need all of them. It's more just to standardize the way that it's presented and to make sure that everybody understands how the separate wires go all together, as opposed to like mixing other colors, which wouldn't necessarily make sense. So some of the questions have been related to the power supply, how we plug everything together, because it's if you've bought the kit, the power supply is actually a DC power supply with like the little jack connector. In your kit, you should have the female connector, which is a DC jack connector. So essentially, when you plug in your robot, you're gonna have to put your jack into the female and then flip the switch. So the little power supply logo on the diagram may not necessarily be clear to you, but it is where you would use your female jack connector. You're gonna solder the negative and positive. The long prong on your connector is going to be the positive, and the shorter prong should be the negative. From that point, you have to use your DC female jack connector and solder the positive wire on it to the little flip switch that you've also got in the kit, as instructed in the diagram. Really, it's pretty straightforward. If there are no fuses in the kit, it is okay. I mean, it's optional, but definitely recommended. So you should probably buy yourself some fuses. You can find them on Amazon or AliExpress. Really, you've got like two options. It's either going to be like a little glass tube where you will have one end of the wire that has like the little part that where you put the fuse inside of it and then screw it together to hold the fuse in place. And the other type is going to be usually it's automotive parts, but it also works. It's like a quick replaceable fuse that you can just fit into a tiny slot, which is like in a kind of a rectangular shape. So you can use those as long as you follow the recommendations, which is going to be a 7 amp fuse if you're using a 24 volt power supply, and it's going to be a 15 amp fuse if you're using the 12 volt power supply with 20 amps. So that's the recommendation, but feel free to do whatever you want. It's up to you. This is just for protecting the circuit, make sure that nothing goes wrong. So with that being said, as for the other wires, if you don't know how Wago connectors work, pretty much these connectors, they all have slots that are all connected together. So let's say I take one Wago connector. You can't necessarily put two wire collars in one of them, otherwise you will create a short, and that will essentially either break your circuit. So you want to make sure that the color of your wires, they are all for the same color and only has one purpose. As you can see in the diagram, we can see that on the left side of the diagram, you can see that sensors also have red wires as on the right side. However, it's a little bit different because when you connect the red wires on the left side of your controllers, this is going to be your motor controller that's going to feed a 5 volt current to your sensor to power it up. Let's say that you take one of the wires on the left that belongs to a sensor and you just put it into a Wago connector where it is also a red wire. You will most likely break your sensor because you're shooting literally 24 volts or 12 volt of current through this Wago connector, and your sensor is supposed to receive only 5 volt. So that'll definitely blow up your sensor and you'll just burn it up really, and you'll have to replace it. So it's really important to just follow the diagram up. It's been verified. It's definitely not perfect. I think that it could potentially be better if we had like kind of a dedicated motherboard or like a PCB for the robot, but for the closed loop setup, it's not necessarily required right now. And I think it's still in an early process, early development, if I should say. So like, feel free to suggest anything if you have suggestions or if you have experience making PCBs. I'm sure that the community will be really open to ideas. But for right now, this is what we have. And the next thing, if I just move a little bit forward, it's gonna be the same thing for like the X, Y, and Z axis. They're pretty easy. You're gonna decide where you want to wire things up. Like, you could wire your robot in a way that all the cables routes to the bottom of your robot, and every Wago connector is underneath the y-axis. You could do that, but it's a personal choice. You could also route half of your wires down to the y-axis, and then have another set of wires that will go into another set of Wago connectors, as shown in the diagram, where you'll have the other wires in the y-axis, in the x-axis. It's really a preference. It's just a matter of how comfortable you are with all of that. If you've got Wago connectors, I definitely recommend to use more than less, because if something breaks along the way, or you need to disassemble something, it's going to be easier for you to just open up these little connectors, remove the wires in them, than to have to actually flip the robot upside down, get to the x-axis, where you'll have to probably do the same thing, but like it's just less complicated to do so. As long as you find a little spot to put them, that's the main quote-to-quote issue. So another question has been related to, like, where do I put my Wago connectors? Should they be like screwed somewhere? Is there any like 3D printed part that I can use to fix them in place? The answer is yes. However, it's not provided with the model. Like, there are a lot of models online that you can use to 3D print, and then you'll be able to just drill a little hole in a spot of your preference and fix it there. Sure, but there has been 1 or 2 mods, I think, for that, but other than that, no official release from Arctos about this, which is fine, by the way. So it's a matter of how clean you want this to be. If you want a good cable management, personally speaking, like, my robot has terrible cable management right now. I need to kind of redo things a little bit, but it's a work in progress. So yeah, it's up to you guys. The types of wires that you should be using, to be honest, there has been a lot of discussions where people would recommend to use dedicated CAN cables for that. Theoretically, like yes, this is a good practice. I mean, this is usually how people would wire things down, but it's not necessarily required, to be honest, especially at that stage where robot is currently in development. We're using the jumpers on the cannibal device, and also the microcontroller at the end, near the end effector, which is the MCP2515 module that's connected to the Arduino. You're gonna have like a termination jumper on this to like close the loop on your CAN devices, which would prevent interference and prevent you from experiencing some issues with the CAN bus devices. So it's you can, however, if you want to use like actual CAN cables, just keep in mind that you may not have enough space to make them fit all the way down to the x-axis, because these cables are pretty thick, as they've got like special insulation around them. Personally, I tried and I just gave up on the idea because the cable was actually way too thick, and I wanted to keep things a little bit cleaner on my end. So for that reason, personally speaking, I used I took the cables that comes with the MKS drivers, and I just split them up however I wanted, cut a few of those, and overall just reused the colors. I used yellow and green for the CAN communications, where the yellow wire is the CAN high and the green is CAN low. And other than that, it's just the power really. So like red for positive, black for negative, and there are a few other exceptions, but like it's mainly this, to be honest. And you have enough wires from those MKS drivers to do the full robot. So I think it's pretty great because first it comes with the kit. Of course, you'll have to cut a few of those and make yourself get your hands dirty, twist a few wires, maybe crimp a few ferrule connectors on them. But like, it's been great, to be honest. It's like the perfect size for this kind of voltage, so I don't see any issues. Overall, just get your hands dirty. Try to wire things down as much as you can. As long as you follow the diagram, you should be fine. And read the instruction. Like, there are a little text in the diagram that you need to pay attention to. The next part in this video wasn't initially planned, but since I have half of it recorded, I thought about sharing it with you so you can get started and set up your X-axis to begin with. So here we go. Alright, so first up, I'll be getting the CAN bus connection set up. I'm using Wago 221-413 connectors. Here's how it's gonna work. We have one Wago for the yellow wire and one Wago for the green wire. Port 1 is where the CAN wires connect to the cannable device, port 2 goes to the X motor, and port 3 is for the rest of the CAN bus wires, which will be running over the Y-axis in the next step. Now that the CAN wiring is sorted, I'll move on to the 12-volt power cables using 2 additional Wago connectors. It's a similar setup. Focusing on the red wire, port 1 connects to our fuse, port 2 connects to our X motor, and the port 3 is for the other power cables, which will follow the same route as the CAN bus wires to the Y-axis.